Welcome to solverfy.
All right, so the first part is to note that constructive interference means that we're going to use d sine theta equals m lambda, m being the order of a fringe. So this diagram is helpful in understanding what theta is. So theta is the angle between the fringes, and L is the distance from the slits to the screen. And so x would be the distance between the slits, the distance between the fringes, while the distance between the fringes on the screen, right? This is the screen over here, and so from this diagram we have that tan theta, just trigonometrically, tan theta is x over L. Now tan theta, the theta is a small angle, right? So for small angles, we can make an approximation, which is that tan theta will be approximately equal to sine theta. And you can check this on your calculator to verify too. And so therefore we have that x over L is equal to sine theta. And so over in here, over in the start equation, we have d times x over L equals m lambda, okay? Okay, so therefore you have that x equals, we just rearranging this equation, is m lambda L over d. And so moving on to the next page, you have, we have for the two fringes, from fringe 1, you have x1 equals m1 times lambda L over d. Lambda L and d are the same, of course, but m is what's going to vary between one fringe and the other. This is the order of the fringe, so m1. And for M2, for the next fringe will be, because of constructive interference, the orders will be an integer number apart, right? So x2 will just be m1 plus 1. It's the delta m is just 1, so your order increases by 1. So this is m1 plus 1 times lambda L over d. That part remains the same. Therefore, the distance between the fringes, delta x, is just x2 minus x1. And let's see what that turns out to be. So lambda L over d, first of all, we can take as common. And you multiply that by m1 plus 1 minus m1. And so the m1s drop out, you're left with 1 multiplied by this whole thing. So delta x, therefore, comes out to be lambda L over d. Okay. And therefore, lambda is d times delta x over L. Okay, and let's go to the next page to work out what that is. Lambda is, so from here d is the distance. D is the distance between the fringes, which is 4.8 times 10 to the negative 5 meters, right? Delta x is the length of the separation of the two fringes on the screen. So that will be 8.5 centimeters, which is divided by 100, it's 0.085 meters. Divide that by, pardon that, you divide that by L, which is 6 meters. What you get is lambda is 6.8 times 10 to the negative 7 meters, which is 6.8, or which is 680. It's 680 nanometers is what that is. And since we know that frequency is equal to speed, which in this case is the speed of light, over wavelength, we have frequency equals 3 times 10 to the 8 meters per second over this wavelength we just found, which is 6.8 times 10 to the negative 7 meters, giving us 4.4 times 10 to the 10 to the positive 14 hertz as the frequency.